Hi, we continue to discuss the A right angle n superscript m. So this time that we define the A right angle n superscript m double dot. So maybe I should say A double dot right angle n superscript m. So that is the present value of this annuity due. So you can see that the time, so the payment, the cash flow start at time 0 and end at the time n minus 1 over m. Except for that, it's the same as A double dot, A right angle n superscript m. So that means the present value is 1 over m year earlier. So if we think about shifting this present value by 1 over m year, then present value is A right angle n superscript m. So when we think about this kind of annuity, always think about relative position of the cash flow above time diagram and below diagram. So remember that A right angle n superscript m, the first payment starts at the 1 over m year after this initial point. So if we have present value at 1 minus the 1 over m year, then the present value is exactly A right angle n superscript m. So A double dot is just 1 over m year later than that. So that means the A double dot right angle n superscript m. So this is equal to the 1 plus I to the power 1 over m. So because the 1 over m year later, it accumulates the interest rate of 1 plus I for 1 over m years. So this is equal to this quantity. Then you can use I superscript m to represent this I. So by definition, the 1 plus I superscript m over m, m's power is equal to 1 plus I. So this quantity becomes this quantity by the definition of this I superscript m. Then we multiply this quantity. And we have the formula for this, and this is equal to 1 minus v to the power n over I superscript m from the previous video. So if we summarize this, this becomes 1 minus v to the power n, and the denominator is m times I superscript m over m over 1 plus I superscript m over m. M, yes. And actually, this quantity, okay, so this is equal to, if we, yes, so if we simplify this, this denominator becomes the d superscript m. So remember that this is the discount rate for 1 over m year, but it's expressed as the annual discount rate. So this is, I think, almost the parallel formula for A right angle n superscript m. So just I superscript m becomes the d superscript m. Or we can say that this is equal to d over the d superscript m times 1 minus vn over d. So that is the d over d superscript m times A double dot right angle ni. So in short, I becomes d when we put double dots. And now we use the one thing, so this quantity is equal to this quantity. We would like to verify it. Yeah, So now that we want to review the D superscript M, this is the discount rate for 1 over M year, but this is annual rate. So this is the nominal discount rate that compounded M3 equivalent to the annual discount rate of D. So what's this quantity? Okay, so at first annual, the discount factor V, so this is equal to 1 minus D. And this is equal to 1 minus D superscript M over M to the power M. So the concept is that the D superscript M is the 1 over M year rate. But we multiply by M because we want to compare, we want to regard it as annual rate. So if we use this one, this is for 1 over M year. So if we take the M's power, that becomes 1 minus D. And the same thing is true for I. So V is equal to 1 plus I inverse, or 1 over 1 plus I. So this is the 1 plus the I superscript M over M to the power negative M. Because by the same reason, because of the same reason. So I superscript M is for the 1 over M year rate. So if we take the M's power, that becomes 1 plus I. Okay, so this equation connects the relationship between D superscript M and the I superscript M. So actually, this should be 1 minus D superscript M over M. So this is equal to the inverse of 1 plus the 1 I superscript M over M. Okay. So from this, that we can derive that the D superscript M is equal to M times I superscript M over M over the 1 plus I superscript M over M. So let me see. So we can take the inverse, so 1 minus. Yeah. So we can, you can say that right-hand side is 1 over, this side is the 1 over 1 plus I superscript M over M. Right. So that means the this one. So we use So we use this term to this side, and we use this term to this side. So then 1 minus this term. So 1 minus this term is equal to D superscript M over M. So 1 minus this. So this is equal to 1 minus, so I superscript M. I superscript M over M over this quantity, 1 plus I superscript M over M. This is equal to D superscript M over M. So we multiply M on both sides, then we can deduce this one. So that is the used here. So now that we completed the proof, and we can say that the A double dot right angle n superscript M is equal to this quantity. So maybe this is equal to this quantity, or we can use this quantity. Yeah. Okay, so now that we can also define the S right angle n and the S double dot right angle n superscript M. So first one, the S right angle n superscript m. So this is accumulated value. So if we make a time diagram, then S superscript S right angle n superscript n is at time n. So for annuity immediate case, the first payment is at the 1/m. So originally the S A right angle n superscript m. So this is in at time 0. But if we calculate accumulated value, we have to multiply 1 plus I to the power n. So S right angle n superscript m is equal to 1 plus I to the nth power times the A right angle n superscript m. So that is 1 plus I to the power n minus 1. Maybe we write one more step. So 1 plus I to the power n times 1 minus 1 plus I to the negative nth power over I superscript m. So this becomes 1 plus I to the nth power minus 1 over I superscript m. So compared to the formula of S right angle n, the just I changes to I superscript m. And how about S double dot right angle n superscript m? So this is defined in the same way as the S right angle n superscript m. So this is again n years later than A double dot right angle ni superscript m. So this is equal to 1 plus I to the nth power times the A double dot. A double dot, we have just derived the formula. 1 minus the V to the power n, that is 1 plus I to the power n. Yeah, maybe I mentioned that this is equal to V to the nth power over the D superscript m. So this is equal to 1 plus I to the power n minus 1 over D superscript m. So the formula is similar to the formula for the S right angle n, S double dot right angle n. So now that we prepared all formulas for A right angle n, A double dot right angle n, S double dot S right angle n, and S double dot right angle n for all the superscript n.